Uh, Hi everyone. So finally I'm live and I'm just going to start the linear algebra. I hope my voice and everything is okay, right? So please confirm once if my voice is audible and the video and everything is clear, right? So thereafter we shall start the session and from now onwards, as I have reached to the new place, I will be conducting everyday session, on various subjects, right? So as you can see, uh, I will, as I have promised that, I'm gonna talk, I'm gonna teach all these subjects as well as mathematics, and mathematics plays an important role, clearing an interview as well as getting a good rank in GATE examination. So please confirm once, if my voice and everything is okay, right? So, you know, so that we can continue our session, right? So just I'm making some setting here because uh, okay, so I'm just making myself a small one so that you guys can yeah, so I hope my voice and everything is fine, and I will be talking some of the important concepts. Already I have conducted around 10 sessions on linear algebra, and I hope you guys might have enjoyed. So in fact I will check myself, okay, whether everything is okay or not, right? So yeah. Okay, so I'm just checking whether my voice and everything is fine or not. Then we shall start. We shall continue our session. Okay. So I think 1 minute. I think link is yeah. So I'm just sharing the link as well to join the session, so that you guys can join us. Last link I believe was not okay. So perfect. 1 minute. I think link is yeah, it is fine now. Yes. So I'm just yeah. So now I shall start the session for today, and today I'm gonna talk about linear combination of vector. Okay, linear combination of vectors. Okay, what is the meaning of linear combination of vector? Already when I introduced linear algebra, right? Starting when I started linear algebra, I was talking about linear combination of column vectors, right? So the same story, the same concepts I'm gonna discuss here as well. Okay, there is nothing new. Okay, so make sure that if my voice and everything is okay, then we shall continue, our session, right? So from now onwards, everything will be smooth till GATE examination, and you guys have the open, like you guys can ask any kind of questions, and you can clear anytime any kind of doubts, right? So okay, so I hope everybody has got the link, and you guys will be able to join us, right? So in fact I will increase myself again. Okay, so before I begin the session, I just want to tell you that my session will be in the morning as well as in the evening. Okay, uh, the mathematics will go in parallel with all the technical subjects, so I will be starting devices as well from tomorrow onwards. You can find the schedule I have shared in the okay. So now everything will be on time, the delivery and the concepts, right? So you have to watch first 10 lectures. I'm not going to teach again the same story what I have taught for 10 lectures. In fact, I have made them public as well. Okay, so please confirm once if my voice and everything is okay. Perfect. So that we can continue our session, right? So today I'm going to talk about the linear combination of vectors, right? So what is the meaning of linear combination of vector, right? So IC Bangalore might ask this year the question from the linear combination of vectors. Suppose we have been given a bunch of vectors. If I give you around 3 to 4 vectors, and if I ask you whether they are one vector can be written in terms of other vectors, okay, that is going to be the linear combination of vectors. Okay, so an expression, okay, linear combination means what? Already I have told you. Suppose we have got a system of equations. Okay, so we write always the linear combination of column vectors, right? Or you can say that an expression. Suppose an expression an expression of the type, okay, of the type lambda1 v1. Okay, lambda is just a constant. You can consider lambda is hi Shubham, yeah, hi Devan. Okay, so please confirm everything is okay now, because today is our first class again. Okay, as I promised, so everything should be smoother, right? तो आप लोगों को अब मैथमेटिक्स साथ में चलेगा और सारे सब्जेक्ट चलेंगे, और ऐसे ही नीट एंड क्लीन वीडियोस मिलेंगी, ठीक है? तो एक बार कंफर्म करना शुभम एंड देवांश, राइट? सो देन वी कैन प्रोसीड अहेड, ओके? So an expression suppose of this type lambda1 v1, suppose we have got v1, v2 and v3 and so on vn, so many vectors are given, okay, in your pocket. Yeah, fine. See, if I give you hundreds of vectors, and if I ask you, can you write them in linear combination of all those vectors? So you should be able to write, right? And what is the systematic way? What is the systematic way of writing them in linear combination? I'm going to discuss, right? So an expression of the type lambda1 v1 plus lambda2 v2. Okay, always we define linearity just by making multiplying what constant with the vector, right? So constant multiply with the vector plus constant again multiply with the vector plus, and so on and so forth, lambda and vn. Okay, this is what we call this as, always keep in mind, is called the combination of vector. Okay, what we call is, we call always that combination of vectors. Okay, v1 v2 and so on vn. This is the meaning of a combination of vector, right? So I will take some examples and we will see. Okay, so what I will do here is, suppose these are the vector given, and I will give you again one more vector v, and I will ask, can this vector be written in terms of other given vectors, okay, in the same space? Till now I did not talk about vector space, but I will discuss vector. What is the vector space, right? I think in the beginning I have told you that what is the meaning of vector space basically, right? Vector space is nothing but, suppose we have been given a vector, okay? Suppose I have given you 100 vectors, right? Okay, and if you are able to add them, okay, if you are able to add those vectors, if you are able to multiply by some scalar constant with those vectors, right? If these kind of operation you are able to perform on the vector, and those vectors are in the same space, okay, I mean to say that, suppose this is one space you can consider, okay, you can say this is a playground, you are playing here, okay. So there are many vectors v1 v2 v3, so many vectors are there. Suppose you are adding these two vectors. If these two vectors are lying in the same plane what you have defined, right, then you can say that is a vector space. Okay, suppose I have taken here, this is a vector, okay, this first quadrant is a vector space. Okay, so if I multiply with this vector -1, okay, this vector with -1, so this vector will be going like this. Okay, now this vector is not in the same space, so we can't say that this vector, this is a vector space. Okay, so what is the meaning of vector space? I will discuss in detail as well. Vector space is nothing but a bunch of vector will be there, okay, in that space, and some of the operations you should be able to perform. First operation is what? You should be able to write them in terms of linear combination of them. Okay, or you can also multiply with the scalar constant. It can be -1, it should not be 0. Okay, make sure that the constant is not 0, otherwise the vector becomes the 0 one, right? Multiplication by constant with any vector is what? It always increases the length of a vector and nothing else, right? It does not change the direction. Okay, but if you multiply with -1, what will happen? If you're going to multiply with -1, so what will happen? The direction will change. Okay, the magnitude is going to be same. Okay, so 2-3 operations are there in vectors. First of all, you can perform addition of two vectors. You can multiply by any scalar constant. Third is combining them, okay, writing them in terms of linear combination. ठीक है, ये 3 ऑपरेशंस आपको याद रखना है. अगर आप ये 3 ऑपरेशन याद रखोगे ना तो फिर जस्ट फॉरगेट, द वेक्टर स्पेस इज नॉट डिफिकल्ट, ठीक है। वेक्टर स्पेस उसके बाद आएगा सब स्पेस, ठीक है। हाँ 180 शिफ्ट हो जाएगा अगर आप -1 से मल्टीप्लाई करते हो तो, ठीक है। ओके, तो ये लीनियर कॉम्बिनेशन का मतलब क्या हो जाएगा, मान लो बहुत सारे वेक्टर्स हमारे पास दिए हुए हैं, ओके, v1 v2 v3 एंड so on and vn, an expression of the type this type, okay, this is called the combination of vector. Now what will be the linear combination of vector? देखो लीनियर कॉम्बिनेशन क्या होगा, इसको तो हम लोग कॉम्बिनेशन ऑफ वेक्टर बोलते हैं, ठीक है। लीनियर कॉम्बिनेशन का मतलब ये रहेगा, अब समझना लीनियर कॉम्बिनेशन बहुत इंपॉर्टेंट है, राइट। linear combination, okay, combination of vector means what, scalar times the vector and sum them up, that is the combination of vectors, simple, okay, multiply with some scalar constant, sum them up, that is the meaning of linear combination, okay। Now the question is what is linear combination, ठीक है, what is the meaning of linear combination? Suppose we have got any vector that belongs to the capital B. Capital B is nothing but a vector space, okay, you can say, so any vector is given, okay, and that belongs to the vector space, okay, so you can say that, and this vector space has got many vectors, you can say v1 v2 and so on, vn, right, in V, okay, these are the vectors which are given in this vector space, you can say this is a vector space, okay। So I will discuss what is the meaning of vector space, okay guys, later, but right now just understand one vector is given that belongs to the vector space, and there are other vectors as well, right, there are many vectors, n number of vectors, okay, and some scalar constants are also there, right, so you can say that lambda1 lambda2 and so on lambda n, okay, lambda n, these are the scalars, okay, they are the real numbers, you can say, okay, these scalars are real numbers, okay, these scalars are real numbers. Now if you are able to write this vector v, okay, as a combination of what, as a combination of lambda1 v1 plus lambda2 v2 plus lambda3 v3 plus lambda4 v4, okay, if you, suppose this vector you are able to obtain from lambda1 v1 plus lambda2 v2 plus, if you are able to obtain this vector v, okay, if this vector belongs to the same vector space, so you should be able to write that vector v in terms of linear combination of other vectors। क्या, मान लो बहुत सारे वेक्टर्स दिए हुए हैं, ठीक है, एक वेक्टर मैंने आपको दिया, और just my question is what, can you write this vector in terms of linear combination of other vectors? You should be able to write. If you're not able to write, means that vector does not belongs to the that same vector space, okay, remember this। So v equal to lambda1 v1 plus lambda2 v2 plus lambda3 v3 plus and so on lambda and vn, okay, this is the meaning of what, this is the meaning of what, linear combination of vectors, okay, linear combination of vectors। So I will take one vector, okay, I will take just an example, so I hope this makes sense। I'm not talking about linear independence, I'm not talking about linear dependence, I'm not talking about anything guys, what I'm talking about, I'm talking about linear combination of vector, okay, any vector can be written, okay, in terms of linear combination of other vectors, okay, you can understand from this as well। Suppose we have got ax equal to v, okay, this is the shorthand representation of system of linear equation, okay, so what is this, what is this, a times x, matrix into vector, okay, matrix into vector, right, or you can say that you are able to obtain b, okay, you are able to obtain b by taking the linear combination of the column vectors, okay, by taking the linear combination of column vector, right, that is the linear combination। If you are not able to get b, okay, by taking the linear combination of column vector, then you can say you cannot write in terms of linear combination of, okay, you can't obtain b then, right, if you are able to obtain b means you are able to write linear combination of vectors, right। So I'm just going to take one example, just remember here, what kind of question you will get. In fact, in previous year, one question was asked as well, right? So what is that example? Suppose we have got one vector x, right? 1, 3, 4. This is one vector. Okay. We say that this vector is a linear combination of, okay, a linear combination of E1, E2 and E3. Okay, these are the vectors given, and these are in future you will come to know that these vectors are standard basis vectors. Okay, standard basis vectors. So you can say this is 1, 0, 0, this is 0, 1, 0, okay, and this is 0, 0, 1. Okay, so these are the standard basis vectors, sometimes we call it, but this x can be expressed, okay, in terms of E1, E2, E3. Okay, if you are able to express x, okay, in terms of E1, E2, E3, then you can say that x is a linear combination of E1, E2 and E3, right? I hope this makes sense, right? So I will take some other example as well. This is simple example, okay? So we always start with the, you know, simple example, and then we move on, you know, complicate our life, right? ठीक है, तो हम क्या करेंगे यहाँ पर, देखो, these are the vectors. You can write them in terms of, in the form of column vectors 1, 3, 4. So 1, 3, 4 can be, you know, can be expressed in terms of lambda 1 v1, or you can say lambda 1 e1 plus lambda 2 e2. So can somebody tell me what should be the scalar constant? Anyone? What is the value of lambda 1, lambda 2, lambda 3? Anybody? Subham, Devans, there are many people, you know, watching us. So can somebody tell me what will be the value of lambda 1, lambda 2, lambda 3 now? So I think everybody will be able to see here. Lambda 1 will be 1 only, obviously, you know, 1 times, you can say 1, 0, 0 plus 3 times 0, 1, 0, okay, plus 4 times 0, 0, 1, right? So this is the meaning of this guy 1, 3, 4. Yes, 1, 3, 4, okay, 1, 3, 4 is the linear combination of E1, E2, E3. And what are those scalar constant? 1, 3, 4. Now you can check, you can get 1. This component you can obtain by taking the linear combination of them. See, 1 into 1, yes, fine. 3, yes, perfect. Okay, so in this manner you guys can always write. I hope this makes sense. Okay, so they will be giving you many vectors, 3, 4 vectors they will give you, and they will ask you whether this vector, any arbitrary vector I am talking about, not only this 1, 3, 4, any arbitrary, any vector can be right, okay, as a linear combination of all given vectors. Yes, blindly you guys can write, कोई confusion नहीं है यहाँ पर, ठीक है? चलो, तो सिस्टम ऑफ लीनियर इक्वेशन से ही सारा स्टोरी स्टार्ट हुआ है, ठीक है? द स्टोरी स्टार्टेड फ्रॉम द सिस्टम ऑफ लीनियर इक्वेशन, and only what we are doing, we are writing them in terms of matrix, and matrix is a combination of all those vectors, column vectors only, right? Okay, we are forming matrix. Perfect. What is the systematic way of finding? Okay, what is the systematic way? Just you can note down these steps, right? Systematic way, right? Systematic way. Okay, so first of all what you have to do here is, first of all you have to, the very first step is write given vector in terms of what? Write given vectors in terms of what? Lambda 1 v1 plus lambda 2 v2 plus and so on, plus lambda n vn, right? And then what you have to do, you have to express the way Devans has expressed here, right? You have to express in terms of non-homogeneous system of linear equation. What? Express in terms of non-homogeneous, okay, non-homogeneous system of linear equation, right? Okay, what is the meaning of this? Ax equal to b format में लिखना है. Then next step will be what? Right augmented matrix. Okay, right augmented, okay, matrix. Okay, and then again you have to choose the best solution possible. What is that? Elimination. You have to perform elimination to reduce it to, you have to perform what? Suitable elimination, and perform suitable elimination, right? Elimination, okay, to reduce it to echelon form, right? The third is, remember, this is very important line, guys. The third is what? If this system has solution, remember, if this system has solution, then given vector can be written or expressed as a linear combination of set of other vectors. I hope this makes sense. Okay, see, once you got the reduced echelon form, you will be able to decide, yes, this system has solution. Okay, the very first example I have given you, that was direct. Okay, by observation you can tell, yes, this guy can be written as a linear combination of other set of vectors, right? But suppose they were the standard vectors, but suppose any other vector has been given to you, right? Then what you will do? Suppose 4 vectors are given, one more vector is given, and we are asking whether this vector can be written as a linear combination of other 4 vectors. So how would you decide? How many times you will multiply, and how you will decide, guys? Can you tell me? You can't decide, right? So what you have to do? You have to go for systematic approach. And this is where in India, there are many students, are not familiar, right? ठीक है, तो क्या करना है? सबसे पहले राइट गिवन वेक्टर इन टर्म्स ऑफ λ1 v1 plus λ2 v2 plus lambda and vn, then express in terms of non-homogeneous system of linear equation, then write augmented matrix and perform suitable elimination, then check, okay, if this system has solution, right? Okay, if this system does not have solution, remember guys, this is very important point. Okay, if this system has solution, okay, if this system has solution, then given vector can be written, or you can say that, or expressed, okay, or expressed as linear combination, okay. I hope this makes sense to everyone. Yes, can be expressed as the linear combination, right? Devan, Subham, other guys, you are able to understand, like you are able to understand now what I'm trying to convey, right? So given first of all, you have to write vector in terms of λ1 v1 λ2 v2. It is very simple. Express in terms of non ax equal to lambda, ax equal to b format, then write augmented matrix, perform suitable elimination. Okay, in this case you will always get non-homogeneous system of linear equation. Okay, perfect. And then you have to check, suppose system does not have solution. Now you should remember when system will be having solution, when system will not be having solution, and so on and so forth, right? So my main objective is, to make you familiar what is the systematic way of going forward, right? Okay, so this is one very important systematic way, and I will give you one question here, right, so that you guys can quickly obtain. So let me take one question and apply our systematic approach. Suppose x is given as 1 3 4, okay, and my statement is this x is a linear combination of, right, v1 v2 v3, and v1 is given, v2 is given, v3 is given, right? So if you are able to solve that, then you can say, yeah, so x is a linear, okay, combination of v1, v2 and v3. So you guys can write in terms of column vector only. I don't have any issue. So this guy is 1 2 3. Okay, this guy is 0 1 2, and this guy v3 is basically okay, let me write properly, otherwise you guys can get confused, right? So v2 is nothing but 0 1 2, and v3 is nothing but -1 0 1. Okay, so v1 v2 v3 we have been given. Perfect. Now what you have to do, now v1 v2 v3 is there, right? So you guys can write them. First of all, the very first step is this, step number 1. 1 3 4 can be written as lambda 1 times 1 2 3 plus lambda 2 times 0 1 2. Here you can't find lambda 1 lambda 2 quickly, yes, because it is not by observation you can't make it, right? Okay, next is lambda 3 -1 0 1. Perfect. You have to solve this system of linear equation. Now then what is the second step? You have to write or what you can do, you can directly form the augmented matrix. I think you guys can directly form, because this is column 1, you can say this is column 2, okay, and this is column 3, and lambda 1 lambda 2 lambda 3 are the variables, okay, like x y z, right? So you can directly form. So the A matrix you can obtain by combining column 1 column 2 column 3, and this is, you can say, the B matrix, okay, what already you know. So you can also tack on this B matrix with the A matrix, that is known as augmented matrix, and then try to apply elimination. And elimination is one of the very powerful tool, okay, to solve any question in linear algebra, okay. So I think elimination you should never forget, okay. Chalo. So what you can do here is you guys can write now the if you want to write lambda 1 the equations, it's okay, but I don't like right, I directly write the augmented matrix, that is 1, you see here 1 2 3 1 2 3, and then it is 0 1 2, and this is -1 0 1. Now augmented matrix means you have to again take this guy 1 3 4 here, right? Now apply elimination. Can you apply elimination? This guy is what you can say, this is A given B, augmented matrix. Now everybody, I think, is familiar how to apply, how to perform elimination, okay. You just consider this guy is a pivot okay, column, and already this guy is 1, it's okay. Make this guy, to art applying operations on row 2 to make it 0. So this will be r2 minus 2 times of r1, and on r3 you can apply. Okay, perfect. So till this point I believe everything is okay, huh? v1 v2 v3, then perfect. So let me go ahead. Yeah, so now what you can do here is just make it this, okay. So it will be 1 0 -1, and this is 0 now, and this can be written as I think this is 1, this is 2, this is 0, this is 2, this is 4, and you guys can write 1 1 -1. Okay, now you can apply, this is fine. Now this is the pivot one, right? What you can do here is you can apply again the elimination, so row operation, right? So you can make this guy 0 below this, because left side it is 0 already, so no problem. So on r3 we are applying row operation, so it will be 2 times of r2, right? Perfect. Next is so this became 0, so let me write here. So it is now 1 0 -1 0 1 2, and this is 0 0 0, 1 1 minus 1. So guys, can somebody tell me looking at this eliminate echelon form, can you get any kind of solution here? Please comment no solution, right? Because you can just see this is having the pivot, this is having the pivot, but this column does not have a pivot. Okay, unfortunately left side also has some pivot, right? So you can say that it does not have any solution because this guy is what? Inconsistent. Okay, inconsistent. Okay, so no solution. Okay, so what is the meaning of this? If it does not have any solution, okay, then if it does not have any solution, then what? You can't write 1 3 4, right, as a linear combination of given vectors. I hope this makes sense to everyone. Yeah, yes guys, yes, cannot be written as a linear combination. So that systematic approach, you have to always carry forward the systematic way of analyzing. In the interview, they will give you a bunch of vectors and they will ask, okay, this vector can you write as a linear combination of the vector? Sir, how can I say directly, right? You have to deliver what? You have to let them know the systematic way of solving, right? So they will be better happy, okay? If you will make them fool, oh, this sir, please do this, that, okay, life is very tough then. I hope this makes sense to everyone, because this, see, we have to learn one concept in a day, but that concept should be, solid. Okay, the moment you leave the class. I hope this makes sense. Okay, perfect. So next is this is one, and one question I will solve. Then we will wind up the session, because today, we started the session, and in the beginning only we have taken 10 to 20 minutes, but from the next day we will take many topics, right? Okay, but tomorrow our class will be again there, right? So yeah, so let me take one question. It was asked in gate 2016, and that to our favorite institute, that is IISc Bangalore, right? For what we are putting our efforts, right? This question was asked by IISc Bangalore only in 2016. So 100% again, the gate is being organized by IISc Bangalore. So this time you might expect questions. So you see what kind of question it was. And I was like, I was not able to solve this question, okay? And this year only, I appeared in this paper, right? So just I'm going to write the question. So what is the question? The question is like, if the vector E1, right? If the vector E1 is equal to, right, 102, okay, and E2 equal to 0 1 0, and E3 equal to minus 2 0 1. There are three vectors they have mentioned: 1 0 2, E2 0 1 0, and E3 minus 2 0 1. Okay, comma orthogonal basis, okay, of a three-dimensional real space. Okay, so you don't have to worry about what is the meaning of orthogonal basis and all. Orthogonal, okay, what is the meaning of basis? Just forget about that. I will discuss, right? But in the question they have written this language, so we will understand what is the meaning of basis. And okay, so this vector, these vectors belongs to the real space, you can say R3. Okay, what is the meaning of R3 like this? Okay, this is a vector space having the dimension 3, right? You see there are three components only, 1 2 1 0 2, right? So three component, three dimension, right? So they have said that then u is a vector, okay, u is another vector 4 3 minus 3, that also belongs to the same space, okay, can be expressed, okay, can be expressed as, now see, can be expressed as, right? Beautiful question, guys. Okay, See, three vectors are there. Now one vector is there, can be expressed as, now options you see. Options are given as, first option is given as what? U equal to, means U can be expressed as 2 by 5 E1, means lambda times something, lambda 1 times E1 minus 3 E2 minus 11 by 5 E3. Option B is given as minus 2 by 5 E1 minus 3 E2, okay, plus 11 by 5 E3. So option C is what? Minus 2 by 5. This is again the vector is equal to lambda 1 V1, or you can say E1 plus 3 E2 plus 11 by 5 E3, right? And D equal to U equal to what? Minus 2 by 5 E1 plus, okay, this is the question. See, these options are given, so you have to solve entire question step by step, then only you will be able to understand the question, otherwise you will not get the answer. So what, when I saw, in 2016, my mind was also the same, the way your mind is working at this moment, right? Linear algebra is just finding adjoint of the matrix, inverse of the matrix, okay, life is over. No, you should understand linear algebra according to the current need, okay? तो देखो यहाँ पर क्या है, ये u को कैसे एक्सप्रेस करना है आप समझ जाओ, lambda 1 lambda 2 lambda 3 इनकी वैल्यू फाइंड करना पड़ेगा, okay? If you don't know lambda 1 lambda 2 lambda 3, then you can't solve the question, right? So what you have to do, first of all, write in terms of lambda 1 e1 lambda 2 e2 whatever, right? Then write augmented matrix, okay? I believe this is fine for everyone, okay? And then apply elimination and then back substitution, because you have to see if the solution exists, right? If solution exists, and what kind of solution will be there here? The solution will be what? Unique solution, okay? Because you can see lambda 1 lambda 2 lambda 3 has some values, means that vector u can be written as a linear combination of given vector, okay? Devans, are you able to understand this question? And everybody out of all who are watching my session, बताइए ये क्वेश्चन कौन कौन कर लेंगे, बताओ कौन सा ऑप्शन सही है? यस, सी, okay, so let me go ahead and tell you. So see, first of all what you have to do here is, first of all, you can write this 4 3 minus 3 as a lambda 1 e1 plus lambda 2 e2 plus lambda 3 e3. Otherwise what you will say? Okay, otherwise what you will say? You will say, sir, this question I can't do because it was not taught to me, right? Why? See, this is not a new question, okay? This is not at all new question, guys. IST IIT expect, okay, you should know these basics. That's why my main agenda to start these kind of a session, on YouTube channel, so that everything gets recorded, and in future I will make them public as well, right? For the moment I'm just okay. So lambda times this vector, lambda 2 times this vector, lambda 3 times the vector, okay? So what are them? So 1 0 2, this is 0 1 0, and this guy is minus 2 0 1, okay? These are e1 e2 e. Now you have to form the non-linear combination. After, what is this? Non-homogeneous. You can write them into ax equal to b format. So this is a B, you can say, and these are the column vector, column 1, column 2, column 3 of a matrix A. Lambda 1, lambda 2, lambda 3 is what? They are the variable, you can say, right? Now you can find, I think anybody can find. So I will just give you the values, okay? I'm not going to solve everything. So lambda 1, lambda 2, lambda 3, right? So what you have to do here, you have to apply elimination. So I'm not going to teach again what is elimination, then apply back substitution, right? Okay, because applying elimination, getting echelon form, going back, okay? Why we are going back? So that you can get unique solution, right? So in this case, you don't have to investigate whether this vector can be written as a linear combination of, here you have to go to solve the complete question, okay, because all the options tells that you can solve this, okay. I hope this makes sense to everyone. So always keep in mind, whenever ax equal to b will be given now, so you should be able to write the right hand side in terms of linear combination of all those column vectors. Okay. If you're able to write, then solution exists. If you're not able to write, then solution does not exist. I hope this makes sense. Everybody, please say, on a chat box if it is clear. Vice versa is also true. Okay? ये कितना अच्छा sentence है. So if you take a look on PYQ in a previous question, you will find some of the options from my statement what I'm making. So lambda 1 and lambda 2 and lambda 3 you will get here as lambda 1 you will get as let me check this, you will get minus 2 by 5. Okay, lambda 2 you will get as 3, lambda this you will get as 11 by 5. Okay. So should I tell how to apply elimination? No, not option A. Okay, option D will be correct here. Keep in mind this, option D. Okay, this is lambda 1. Okay, see they have given this kind of a similar kind of options, right? Only plus minus you have to take care of. Okay, so I think you might be making some mistakes. So check lambda 1 you should get minus 2 by 5, lambda 2 3, and lambda 3 minus 11 by 5. Okay, so I think you might be making somewhere in sign. Okay, or if you want I can give you as well. So A given B, right? So this is augmented matrix. So you guys can write 1 0 minus 2, 0 1 0, 2 0 1, right? And this is 4 3, and I believe this is minus 3 only, right? Yeah, minus 3. अब इसमें लगाना है तो I think anyone can apply. So Devansh, have you checked? Yeah, option D is correct, right? So this was all about today's session, and what I'm going to do in the next session. Again, just I will tell you so that you will become more appetite, right? You will become more hungry. Okay, if you're hungry, then life is, just for others' sake, please provide solution. Yes. So what is solution? What is that solution? See, I have given you A given B. Now you can apply the elimination. So applying elimination means what? Simply, you have to only apply here row operation, right? Because R2, this guy is already 0 below the pivot, right? So R3, so R3 minus 2 times of R1. Okay, so next, after applying this guy, this row operation, okay, A given B become 1 0 minus 2, okay, and 0 1 0, okay, and this becomes 0, and this is already 0, I believe. Yes, and this guy is 5. Okay, yes, it became 5. Okay, and 4 3 minus 3. So this is already in echelon form. Okay, this you have got. Yes, I use, yeah, sure. So see, this is already in echelon. This has column, this has, this column has pivot, this column has pivot, this column has pivot. Okay, because what is the choice? What is the how we no, we will not take lambda as imaginary here, but in future you will find that if your vector component, okay, if your vector component is having a complex component, right, then lambda can be the imaginary one, right? Okay, that you have to make sure. But here we are taking the real vectors, okay, whose component is whose component is what? Real. Okay, real space we are considering. Okay, by looking at the component. Okay, yeah, because the matrix element can also be the complex one. Yes, Okay, those kind of matrix also we will in future we'll see that they are also known as Hermitian matrix, and so many concepts are there, right? So keep this in mind. If the element of the vector, component, okay, they are real, then lambda should be always real. Okay, here in this case, okay, so see, already we have applied here some row operation. They are 0. Below this it is 0. Now you don't have to apply anything. Okay, now you just go back. Okay, so what you have to do, next step should be here, back substitution. Okay, back substitution. What is that back substitution? So depending upon, so what is the significance of imaginary coefficients in vectors? See, in this case, what I'm trying to say here is that right now I'm talking about real space. Okay, so you have to focus on real space, right? When we will discuss the complex matrix, okay, where the element will be complex, okay, so at that time we will see whether then we will discuss the significance of this your question and everything, right? For the moment, just focus here, right? So yes, so 1 1 1. Now how to apply back substitution? So it should be like this, one question at a time, right? So it should be 1 0 minus 2 0 1 0 0 0 5. Now you write here lambda 1 lambda 2 lambda 3, and the right hand side is what? I think this is minus 11. Okay, this is minus 11. Okay, yes, this is minus 11, so this is 4 3 minus 11. Okay, though these lambdas are constant for this moment. Okay, so you have to take them constant, and they can be real, they can be imaginary. Okay, depending upon the problems, right? So 4 3 minus 11. Okay, now the thing is, how can you write? So here 5 lambda 3 equal to minus 11. So from here lambda 3 equal to what? Minus 11 by 5. Okay, so this is how we can evaluate these constants. Okay, so everybody is able to understand now how back substitution will be applied. Quickly confirm. Yes. Then if you have got lambda 3, then you can write here lambda 2. Lambda 2 is direct. Okay, lambda 2 is straightforward. Lambda 2 is 3 directly, right? I don't have to solve, in fact. Lambda 2. Lambda 2 is direct. Okay. Next is lambda 1 minus 2 times lambda 3 equal to 4. So please solve that. You will get as minus 2 by 5. Okay, so I'm not going to solve that. Okay, so I'm just writing here lambda 1 is going to be minus 2 by 5. I hope now this solution is clear. Perfect. Dekho, systematic way of solving question you should always know. Okay, because the moment you see the question, my main agenda will be always in the class. See, suppose any question you take, be it analog circuit, devices, communication system, mathematics. The moment you see the question in the main exam I'm talking about, right, you should be having that algorithm. Okay, from here I'm going to start and this is my destination. Okay, because you're not doing research. Okay, research is what? Research is you have to take some problem which is unknown, completely unknown, you don't know the destination, right? That will take a lot of time. But something which has solution, okay, which you can always solve it. So keep this in mind. So this is what I wanted to discuss today, and the appetizer for next class I'm just telling you is linear independence of vectors. Okay? Most important question to be asked in the interview, independence of vectors. Why I'm talking all these linear independence of vectors, then I will talk about systematic way of investigating Li and Ld. Okay, and then we will talk about linear span. Okay, then we will talk about spanning set. So the moment you understand these three concepts, okay, these three concepts, guys, you will be able to understand what the big word basis and dimension. Okay, if you don't know what is the meaning of linear span, yes, Ayush, it will be, yeah, shortly it will be started, right? So yes, yes, they will take some value, 100%. Yes, yeah, they should take now. So you should be able to solve, okay? Because if you have got the unique solution, means you can find the value of the variable, by applying what the so basis and dimension, right? So to understand basis, keep in mind always. Suppose this is a Li part, okay, linearly independent vectors, and this guy is what the spanning sets, okay, or we call it generating set. Okay, spanning is nothing but generating, okay, generating new vector. Okay, so taking the intersection of them, this guy, the vector which belongs to the intersection of these two concepts is known as basis. Okay, so basis is nothing but a combination of vector which are linearly independent as well as having spanning set. Okay, they can be spanned as well. Okay, they can be generated. Okay, this is very important concept, guys, and I believe this is you know okay. So if okay, so now it's time where I can take your doubts, right? If you have any doubt, because my main objective is when we wind up the session, you should not be having any kind of doubts, right? What do you want, what you don't want, how was the session, okay? Everything you have to write so that I will come to know and I will try to improvise the concepts, right? Uh, yes, there will be there can basis nahi. देखो, in what the basis is what the collection of vectors, right? Basis is the collection of vectors. Okay, basis is not a number, remember, basis is a collection of vectors. Okay, and dimension will be the number of vectors which are present in the basis, right? Very beautiful concept. Whenever I teach now, I feel, in fact, oh my god, how wonderful these concepts are. So basis is what the collection of vectors which are aligned as well as can be spanned. Okay, so they should belong from the spanning sets as well as lights. The intersection of those two concepts, okay, will define the basis, and number of vectors, okay, which are present in the basis, right? That is known as dimension. So dimension is a number, right? But basis is a collection of vectors. Don't say number. Perfect. Okay. So I use you can you can uh, you can get added in the group as well, right? Because I always share all the links. Oh, concepts, actually these concepts are not taught anywhere, right? So my main objective is कि ये concept आएंगे तभी आपको future में मजा आएगा, है ना? Once you will get into ISC, or before getting into ISC, you will be given a chance for the interview. So because this time Subham Sahib went to IIT Kanpur as well, right? And he was exposed to various questions from linear algebra. So his yeah. Oh, you are already in. Okay, I don't know. Okay, so you can let me know. You can ping me as well. So because I don't know whether you are there or not, right? Okay, so we will get in touch. Okay, chalo. So I hope everybody might have enjoyed the session, and because of my session, next session is there, right? So I will be meeting tomorrow in the morning by 8. We will discuss signal system. Okay, the same story. I'm gonna teach you how to multiply two signals and how to add two signals. Okay, how to multiply, how to add ramp and the constant. Okay, so many things I'm gonna discuss. Then we will keep on building our foundation strong. Thank you. Okay, we'll meet in the next session. keep learning and okay, thank you.